Hey guys, so welcome to my channel, and in this video I'll be discussing about the Fibonacci numbers. This is going to be a part of LeetCode series which I'll be discussing some of the problems in the future. So I'll be discussing three different solutions for this problem with different time complexities. So one is going to be O of 2 to the power of n, O of n, and O of log n respectively. So let's get started. So first one, I'll be discussing about the recursive approach, how we'll be defining. So first, we initialize the base cases or initialize the base cases in this case. So if n equals to 0, return 0. Wow, this is so many mistakes. If n equals to 1, return 1. Then again, you just have to return the value. There is no need to initialize any kind of values here. So return fib of n minus 1 plus fib of n minus 2. So we'll just run the code. Okay, so why this takes O of 2 to the power of n is because every time we go through this nth value, we just have to calculate n minus 1 and n minus 2th value. But for n minus 1 also, we just have to calculate n minus 2 once again. It won't depend upon the value which is already being calculated here. So because we're calculating the values multiple times, that's the reason why it exactly takes it takes approximately of 2 to the power of n. So next we'll be discussing about O of n approach, that is going to be dynamic programming. So again, it's the same approach. First initialize the base cases, return 0 if n equals to 1, return 1. Next, now initialize the values, what all values you need. So first it's going to be the all the Fibonacci numbers, like each Fibonacci number depends upon the two previous values. So first initialize the result, or define the result in this case, and define the previous one, which is going to be the first preceding value, and previous 2 is second preceding value. Next, for int I equals to 2, I less than equals to n, I plus plus. So since we already have 0 and 1 values, we just have to start calculating from I equal to 2, and we just have to find the nth number, that's why it's equal to. So what all we have to define? First, calculate the result in each iteration, that is going to be the result equals to prev1, prev2, next prev2 equals to prev1, prev1 equals to result. So for each and every iteration, we just have to update these previous values, so that once again when it updates the result, these will automatically get updated and get added and assign the result once again. So one thing is missing, that is defining the previous values in this case. So previous one, it's going to be the f of 1, like first preceding value, that is going to be the 1, and previous 2, it's going to be the second preceding value, that is 0, and afterwards it will automatically calculate all the preceding values. So yeah, that's will take O of n because it only iterates to n times. Okay, this ran successfully, and moving on to the third problem, that takes O of log n time. So that is golden ratio. We just say this golden ratio, but all the like the numbers of the Fibonacci numbers always depend upon this golden ratio. It's nothing but the power of this number. So let's just see this. Maybe I'll be confusing you if I just throw up the details. So while writing the code, I can just explain everything. So that's golden ratio is nothing but 1 plus square root of 5 by 2. Okay. So first define this golden ratio, and then what you will return, that is the power of this g comma n, like whatever Fibonacci number it is, we have to do power that many times, and we should divide this number by square root of 5. And once this is done, all the numbers are going to be the float, so we just have to round up these values. So basically this is nothing but a round of this power, nth power of the golden ratio divided by square root of 5. So let's just run the code and check what happens. Okay, this ran successfully. Yeah, I think the whole code has ran successfully, and the percentages here even doesn't matter, like they might change or they may remain the same every time we run the code. So yeah, I guess that's it for this problem, and thank you for watching. If you need any explanation improvements, just comment down below so that I can improve in my next videos. Thank you for watching.